In this demonstration, we're going to set up network load balancing. What I've got set up here is two computers, computer 1 and computer 2. They're going to be the two nodes of our NLB cluster. They're both running IIS, and they both have a default home page. Let's take a look at computer 1. On computer 1, we open up Internet Explorer. I ask for the default website for computer 1. The home page then says this is computer 1. Switching over to computer 2, a similar situation happens. Asking for the default web page for computer 2, we get the home page saying this is computer 2. Now I put different home pages on here that is different content so that when we set up the NLB cluster, we can see how the client can get bounced back and forth between the servers. Normally, of course, in an NLB cluster, you would have identical data on each node. That way it's all transparent to the user as to which server they're on. So IIS has been installed on both computers. NLB is installed. You can tell by going to Network Connections and looking at your local area connection properties. And in the list now, for all 2003 server versions, you'll have network load balancing. Now, if you come here and check the checkbox, this would be the manual way to set up network load balancing. And with network load balancing, you set up a cluster IP address that is the same cluster IP for all nodes, an FQDN for the cluster, a mode, a unicast or multicast mode for the cluster, and then the individual host itself will have settings as well. So individual IP address, individual unique ID, etc. Well, we're going to set this all up in Network Load Balancing Manager, a graphical way to do that, a GUI way to do that. So we'll switch back over to computer 1. And on computer 1, we'll go ahead and open to Admin Tools and Network Load Balancing Manager. Now actually, before we set up a cluster, one thing to consider is how are clients going to access our cluster? Clients need to access the cluster IP address. They're going to do that through the cluster FQDN. So we actually also need to open up DNS. So in DNS on computer 1 in the westsim.private zone, we're going to go ahead and create a record for the cluster. Now looking in the A records here, we have records for computer 1, 2, 3, etc. And in this zone, we're going to create a new host record simply called cluster. And we're going to map an IP address to that name. So if someone tries to ping cluster or ping cluster.westsim.private, they're really trying to ping 1.250. Let's go ahead and test that out at the command line. We're going to ping cluster. Now notice when we attempt to ping cluster, it tacks on the suffix westsim.private, and it puts in the correct IP address for the cluster. And we have not yet set up the NLB cluster. That's the reason for no response in this case. Once we set up the NLB cluster, we should get a response. And in fact, it's not even going to tell us which of the two nodes we're getting a response from. It'll just say reply from 1.250. So by having the NLB cluster, we're abstracting all of the load balancing from the clients, from the client end of things. So DNS is set up. Now we need to set up Network Load Balancing Manager and set up a cluster. So we'll right click and say new cluster. So what's the cluster IP address going to be? 192.168.1.250. Default Class C subnet mask, and we're going to change the FQDN of the cluster to cluster.westsim.private. And we're going to operate in multicast mode. That allows nodes to communicate with each other as well as to clients. We're just going to have one cluster IP address, the 250. We don't need additional cluster IP addresses in this scenario. Now port rules, if we edit the default port rule, we can specify which protocols and which ports we actually want to load balance. You don't have to load balance everything between the two computers. For example, I could say to load balance only port 80 traffic between the two computers. And now for web traffic, that will be load balanced, but nothing else will be load balanced. Now it's asking us which node we would like to be the first node of the NLB cluster. And for that, we will choose Computer 1. Computer 1 has two functional NIC cards. We're going to use the local area connection 1 here, the .241 address. It's asking what priority ID or unique host identifier ID do we want to place here for Computer 1. We'll just put ID of 1 here. And then notice, in addition to a cluster IP address for all nodes in the cluster, we have a unique IP address for each node of the cluster. So .241 is Computer 1, .242 is Computer 2, .250 is the cluster IP for both. And so it'll take a second here to add the first node to our cluster. And while we're waiting, down below, you'll notice that we have log entries, so we can get information about what's going on with our NLB cluster. At this point, it's telling us that we're waiting for an operation to occur in Computer 1, and we know that operation is to get Computer 1 added to the cluster as a node. To the right-hand side, you'll notice the cluster name, the FQDN, and the cluster IP address. To the left-hand side, we're now green. Green is good. Clicking on the cluster, you'll notice the status for Computer 1 is that it has converged. The process of converging means that we're adding new nodes to the cluster. So if we add a second node to the cluster, we would converge on that node and then balance between the two. If you remove a node from the cluster, removing a node requires convergence so that all the computers that are in the cluster know that the computer was removed. So we've got one node added. Let's go ahead and add a second node to our cluster Computer 2. Add host to cluster. So we'll add Computer 2 to our cluster. And it has detected one valid network interface card on Computer 2. And we'll put an ID of 2 on this, and notice the unique IP address for Computer 2. It didn't ask us for the cluster IP address because we're adding it to a cluster that already has a defined IP address. While we're waiting, you'll notice NLB is not yet bound, but when it is, it will be converged. And there we go. Computer 2 has been successfully added to our cluster. We have green. Green is good. Green status message. And looking at the cluster, it tells us that the nodes have been converged. So we do have our two nodes in the NLB cluster. Now, how can we test this out? How do we know this is actually working? Let's go back to the command line. At the command line, we're going to go ahead and ping cluster. Now, cluster is added with the suffix, the default domain suffix here of westsim.private, and in DNS we specified 1.250 for the cluster IP address. And notice we're getting a reply from 1.250, whereas before we got no reply at all. In fact, there is no computer on the network that has a unique IP address of .250. What's going on here is that one of the two nodes of our cluster is actually doing the reply, and they're replying saying that they're from the .250 address, when in reality they also have a unique IP address. So this is a part of the magic of clustering. It's all abstracted from the client. The client has no idea. All we can tell is that we're pinging a cluster and getting a response from a single IP address, when behind the scenes we have two nodes, or up to 32 nodes, and any one of the 32 nodes could be responding. Let's also test this in the browser. So in the browser, we're going to do a web request for cluster. And notice we got a response back from Computer 1. Now if I refresh this, we're going to continue to actually get Computer 1 because of caching. And even if we delete the cache, I found that even then sometimes that won't do it. We'll still get Computer 1 information. Reason being is that the priority ID is 1 on cluster node 1. Well, let's say Computer 1 fails. So we'll go to our NLB manager, and we will go to control host, and we will stop the NLB service on Computer 1. Notice we get a red error message. Back at the command line, we're still getting a reply. Now to really test this, let's go ahead and access the cluster from a computer outside of the cluster. So I had computer 1 and computer 2 set up using remote desktop protocol. So this computer is SLSRV3. So to really test our cluster, let's go to the command line. We'll ping cluster. Notice that does get resolved successfully through DNS because this computer is pointing towards computer 1 for DNS. And using the browser, let's go ahead and test that out as well. So this is a computer outside of the cluster. And all I'm asking for is cluster. And through DNS, that should get resolved to the .250 IP address. And through NLB, I should get to one of the nodes. Now, node 1 has been stopped, and therefore node 1 should not respond. And there we go. I got computer 2. Let's do a vice versa on that. I'll go ahead and enable node 1 and disable node 2. So we're back on computer 1 here. I'll go ahead and start computer 1. Yellow means it's in the process of converging. So green is good. Red is stopped. Yellow means it's in the process of converging. When that's done, we'll go ahead and stop computer 2. Okay, to refresh the display, I closed out Network Load Balancing Manager and just reopened it. And now we can see that there are two green squares here. They're both converged successfully on the cluster. So to test this out one more time, we're going to go ahead and disable node 2 or computer 2. And this time, instead of stopping it where we got the red square, I'm going to suspend it, which is roughly the same thing. It's not going to respond to requests. And I just wanted to show you that suspending gets you a gray square. So node 2 is now suspended, and we're going to go ahead and test out the cluster then. So back on our very first computer, we'll open up a browser, and we'll ask for cluster and see what happens. And notice now we get computer 1. So node 2 is disabled, we got computer 1. Node 1 was disabled, we got computer 2. So that's how NLB works.